think I should be live with everybody right now. Let's go and do our checks. Looks like YouTube is working, so that's good. Gonna pull up Twitch, make sure I'm live there. Looks like I am, in fact. So, if you guys don't recognize the character on the build plate shown on screen right now, that is Arlecchino from Genshin Impact. My sister's a big fan of the game, and her birthday is coming up this weekend, actually. And so I am trying to make a little figure for her. So I'm not a total weeb. I do have some social skills, and I'm just about done with that. Actually, right now it's sending over the Wi-Fi to my newer Saturn 4 Ultra printer. I got that about 2-3 months ago. It's been pretty nice, but resin printing is a whole new animal. It's not something I am very good at yet. Let's see. Let's just make sure that things are coming through correctly. Cool thing about using Restream is I can send messages to all of my channels at the same time. I've never been able to do that before. It's pretty neat. All right. Okay, yeah. Let me know how it goes, Wills. I see you're on Twitch and YouTube. I should be good in both cases. I think I'm actually getting to a point where I kind of know what I'm doing. All right, cool. Cool. All right, so looks like the resin printer is started its thing. So I'm actually going to switch to my secondary screen for a bit. There's a couple things I want to go over. So let's move OBS out of the way. And let's open up Photoshop. Oh, and I thought of something to kind of spice up the stream a little bit. I do have a paid Apple Music subscription, so I should be able to stream some non-DMCA music. Okay, how's that going? Let's see, I can increase the volume on that a little bit actually. All right, Wills, tell me, can you hear the music? Does it sound good? Where's my stuff? It's right here. All right, cool. So, first thing I gotta do is I gotta turn these notes on my phone into something that you guys can see. So I'm going to scoot my graphics tab up closer to me. All right, I'll bump it down. It's at -25, I'll do -30. Why did that happen? Oh, well, it says it's still playing. I don't know. Apple Music is always a little weird. Okay, so, anyways, let's draw a rectangle to start. Let's make that a nice bright color so that we can see what's going on. Seems that Twitch is like a tad bit quieter. Huh. I don't know why that would be. I'm sending the same signal to both. Okay, so this right here, oh, I need a bigger line. Can't see that. This right here is, I don't want the soft brush though. I like this one. Okay, there we go. That's a good looking arrow. So this bottom box is a magazine. And this top box is a magwell. And the way that an AR-15 style magazine works, and extra emphasis on style because we're not using an actual AR-15 mag, but Airsoft does try to mimic a lot of the real world weapons. The way that it works on the Airsoft gun is you have a rectangular window cut into the side of the magazine, and then you have an arm that reaches across and puts a little step into that window to hold it up, and it's spring loaded, and so when you push it to the side, the magazine can drop out. When it is held in place, then the magazine is also held in place. So something I've been working on is some ideas for how we might turn this into a design that will work with a P8. So let's pull up a picture. So the P8 looks like it uses a pretty typical AR style magazine release, except that it really doesn't. The reason why I say that is because this gray piece right here is what would usually do the release mechanism, but it's not at all lined up with the notch in the magazine where it would actually be able to do that release. So we need to come up with a way to accomplish the same thing without using that hardware. So I've been tinkering a bit, and when I was at work, supposed to be taking care of patients, I came up with a couple ideas. Oh, the other thing I need to touch on is it looks like this triangular piece here is what is supposed to be actuating the magazine release. And it gets a little confusing because the P8 has it also has a AR-15 style magazine release on the right side of the gun. So you would reach up with your index finger, poke that, and then the magazine would drop out. So I think it would be cool if both of those were operable. And so I've come up with an idea of how we can achieve that and create some standardized hardware on the lower receiver that will work for all the different models of P8 that we're trying to accommodate. So let's go ahead and group these layers. Then we can hide that pretty easy. Actually, you know what? Actually, if I'm being smart about this, I should turn on symmetry mode. So what we're looking at is a front or back view of our magazine release mechanism. These rectangles on the side here are those triangular sections that we see on the design. And I actually have a bunch more pictures that I can pull up for reference. See, I want to avoid showing that picture because I don't think I'm supposed to be able to show it in public yet. Here we go. So if we look at this triangular piece, it looks like we have 5 millimeters-ish of travel. We'll be able to make a better estimate when we're actually looking at the P8 SC in our CAD software. But it looks like this moves vertically about 5 millimeters. So let's denote that with another color. So that can move 5 millimeters. And I want to control everything with one spring to keep it pretty simple. So the way that we can do that is we can use some cam profiles. Oops. Actually, I need that green back. actually, okay, minor issue, but I did mess that up. It needs to be like this. It needs to be oriented vertically. So this is still connected to our vertically moving piece. Now let's grab another color to represent the cross piece. Actually, I should just keep this drawing open. E for erase. And then this is a ground plane over here. So it is not allowed to move. Actually, I need to place that slightly differently. Place it about there. And this pin is allowed to move through it. And then we have a spring. And a cap to the spring. So basically something for it to push against. And it would be pretty helpful for this if this piece here were threaded. So we'll draw some threads like that. Now, what should happen is if this is the thumb button on the side of the P8, if that red section is this, then when you push that in, it will move from right to left, because we're looking at it from the back. And this inclined plane of the thumb button will push on the matching inclined plane of the vertical moving piece. That will make it so that the vertical moving piece moves down. And the rest of our design is going to depend on that downward movement. When the spring pushes the button back out, then it will be pushing against this inclined plane, which will lift the mechanism back up. And so there's a couple issues that we might run into here. One, it could end up being more friction than the spring is able to overcome. And if that's the case, then we'll need to come up with a way to reduce that friction. There's a number of options, but because of the size that we're working in, it gets pretty tough because we only have like millimeters of play space. But let's keep going through the design process as though that's going to work, and we will cross that bridge when we get there. So then the next part of my master plan so this is a top view. And then we need another rear view. Since we know that this piece moves up and down, we can use that to translate into a rotation in a perpendicular direction. So again, we have a cam profile. And this time what's going to happen is when this piece moves down, it will make this peg, which is connected to this teal piece up here, it will cause it to move to the left. Well, if that happens up here, you can envision a left-way movement is actually rotating this whole piece clockwise, which will result in a movement over here. And because this lever arm is bigger than this lever arm, or sorry, smaller than that lever arm, a small movement here equates to a much bigger movement up here. And so that's how we're going to get the magazine release for the AR style mags to work. We'll have a cross pin actuated by a spring, mated together with a set of cams for the vertically moving portion. When that vertical piece moves up and down, it will cause this teal piece to rotate. But we don't just have AR style mags, we also have SMG style mags because we're trying to make the P8 SC at the same time. So let me grab some visual aids that I got here. I had these come in recently, which is great because it means that we can keep the project going. So here we have a SMG style magazine, and the way that it's held in is it has a tooth that indexes it into place right here. So we need a way to grab onto that tooth. With the AR style magazine, it has the rectangular window that you can just make out if I get the lighting right. Right there. So we're actually going to be putting them in backwards. And the reason why is when both of these are loaded backwards, it brings the feed ports for the magazines a lot closer to the same position. And so that's going to simplify the design process for me a lot. So matching this up with our drawing, this is how you would be looking at that magazine. So feed port at the bottom, windows up here at the top. So we need to accomplish a similar mechanism for the SMG. Using that downward movement, we want to be able to release or grab onto the tooth sticking out the side here. And I've come up with a way to do that, that again should work. So this is a side view now. This is our piece that moves vertically down, and all we have to do is connect it to the tooth over here with a pin located above it, and then that pin, I didn't line these up very well. That pin is rotated by, or the arm rotates about the pin based on the downward movement of our green piece here. So now what we need to do is we need to do some math to figure out how much we actually need to be able to move these pieces. What's going to be helpful is knowing the dimensions of our SMG magazine. So I've got my pair of calipers here. Wipe off the jaws. Okay. So I'm getting 35.85. So I would actually want to round up a little bit because we need to build some tolerances in. So the closest one is 36, and you might think that 36 would be enough, but you would be wrong. And the reason why I know that is because I've already done it. So let's actually open up the P8 file that we have going. Ah, see this? Got some work done on it. So I've gone ahead and modeled the magazines, this one that we've got here. And if we isolate that one, and then we take a measurement off of it. I measured that as 3.6 centimeters, or 36 millimeters. Now, I know that that's a problem because I also went ahead and tested the fit of the mag well. And you're gonna have to pretend you didn't see this for a minute. You can see this one. Let me get that closer to you guys. So we've got the bearing logo. It says P8SC on it, 10 by 25 millimeters. And it's been done with my FDM printer with a 0.6 millimeter nozzle, so it's not very detailed, but you do get the idea. The issue that we run into is if we try to load the magazine into it, which is not suggestive at all. There. Like, it does work, but it's quite stiff. I don't want it to be quite that stiff. Now, we are working on a P8 AR, so let's pull this guy out. And let's see. Goes in like so. This one is sliding very easily. In fact, too easily. So we can learn something from the fitment of these two, because one is too tight, the other is too loose. So we have our P8SC as we said that this was 35.84. I'll just put my units here. So everything's in millimeters. We have 35.84 and then we idealize that to 36. That's too tight. And then we also have the width of the magazine. Which is 24. And I believe I kept this the same here as well. Yeah. So we know that we want it to be a little more tolerance than that. We want it to be less tolerance than this. So let's go to our CAD. You might be wondering to yourself, how did I make this? Because I've been working on a P8SC, and that's not what we have in my hand. This is clearly for a P8 AR. Well, Onshape allows you to do something called a configuration. And what I've got here is I've got all of these different variables controlled by what configuration we are looking at in the software. So you can see there's a lot of P8SC stuff, but there's also a lot of P8 AR stuff. So if we go over here, we can actually select our configuration. If I just pick P8 AR, it rebuilds it as an AR. Really cool. So let's take a measurement of our AR style magazine. .2. And you are absolutely right, Wills. One of the great things about 3D printing is, in fact, that you can prototype and not be losing a ton of money every time. Again, let's isolate our magazine. So we rounded up to 8 centimeters, which is 80 millimeters. And we made that 2.6 centimeters. No, wait, 26 millimeters. And in reality, it is 25.04. So let's just say 25.1. Actually, no. 0.4 would round down to 25. So I'm going to pull up another browser window. We're going to go to Desmos. And I'm going to switch to the main screen so I can have a bigger window to play with. I'm running out of desk space. I need an even bigger desk. Probably going to do that in a future video, because I do have a lot of ideas for a future version of my desk. Okay, so we've got 36 millimeters minus 35.84. We've got 24 and 24, which is a 0% tolerance. Got 80 minus 79.2. And we've got 26 minus 25. So if we look at this, our tolerances are all over the place right now. And that's a big part of why the fitment is not very good. I'm not happy with the AR fitment because it's too loose. It has a lot of side-to-side play and a lot of front and back play. So we want to reduce that, but increase it on the SMG side, because this has no play to the point where it's actually quite difficult to get the magazine into place. And we also need to fix some very basic details because it's not extending up into the mag well like it's supposed to. So a rule of thumb that I've found very helpful, and one that I've actually stolen from another YouTuber, let me find his name actually, because he does make a lot of really good engineering videos, and it would not be fair of me to talk about this and not give you guys a reference point. Come on. David Malawi, I think it is. Let's see what that pulls up. Yeah, this guy. So, great engineer. Very obvious that he's got a lot of experience in the field, so he's a great resource to pull from if you want to learn how to do something. And I like his videos, but they are kind of all over the place a little bit. But specifically, I think that everybody should watch this Borrow a Tolerance Mindset for Designers. It's changed a lot of how I am looking at doing my own designs. To sum up what we need here, we're going to take half the diameter of my nozzle and add that to all sides. So the reason why we are doing that is, let's see. Let's switch back to this screen. We have something called accuracy and precision. So if we have a target, accuracy is how close to the target you can hit. Precision is how well you can repeat that. So an accurate target that is both accurate and precise might look like this, where you get a cluster of readings right in the middle of the target. If it's accurate but not precise, you can get readings that are spread out, but they're still centered around the... No, sorry, this is precise but not accurate, because positionally our average is where we want it to be, but our accuracy is not enough that we're actually hitting the target the way we want to. We can also have the reverse, where we can have it be precise but not accurate. So we can have a really close grouping, but it can be off target. So for the case of our 3D printer, we have it where it is more precise than it is accurate. So it does really well at doing these X and Y movements. So if I tell it to go to this point here, it will do a movement and it will get to that point. And it will actually interpolate. So instead of doing a side and then an up movement, it will do this diagonal to get to that point. But it will get to that point. The problem is, once it's there, it's kind of all over that point because it's not very accurate. So it's very precise, not accurate, so we can tell it to go anywhere we want, but the accuracy of those details once it gets there is not something that we have a ton of control over. So we have to increase our tolerances. We know that the details are going to be in the right location, but they might not be the right size. So for our purposes, what we're going to do is we're going to increase our real world dimensions by 0.3 millimeters on each side. My nozzle is 0.6 millimeters total. So 0.6 millimeter nozzle. We're going to use 0.3 millimeter tolerance. So then let's pop back into Desmos. If we have a real world measurement of 35.84 and we add 0.3 to that, but we add it on both sides, that's going to give us 0.6, which gives us a overall measurement of 36.44, which for the sake of ease, I'm going to round down to 36.4. If we have a real world measurement of 24 millimeters and we add, and the reason why I'm saying 0.6 now is because it's 0.3 on one side and then it's plus 0.3 on the other side, right? So overall it ends up being 0.6, but we get a measurement that's 24.6. Okay, that is indeed greater than the measurements that we have on the SMG side of things, which should result in a looser fit. But if we look at now our AR fits, okay, we have 79.2 plus 0.6. That gives us 79.8, which is very close to 80 millimeters, but it's not the same. And so that little bit might just be enough to snug up this fit and make it feel a lot better. And the same thing happens when we jump down to the next one. 25 plus 0.6 is not 26, it's 25.6, which will help snug up the side-to-side play. There we go. That's a better way to show you that. So the closer these are together, the better that fit is going to be, but we don't want it to be so tight that it's uncomfortable to put the magazine into the gun. So let's adjust these now. And I think I was naughty and I did not define these as variables, so I have to I should do that. Desmos on my other window so I can copy these down easy. This needs to be length. No. Depth. This one needs to be okay, so now we've got those defined. The other thing that I've gone ahead and done is I've organized, well, I've gone through and renamed most of these features in the CAD so that they're a little easier to understand what they are. But if we go and edit this P8 AR mag body extrusion, and we change this 2.6 centimeters to be instead, oh, shoot. We need to move all of these up. There we go. Come join your friends up here. There we go. Now we should be able to reference it. So P8 AR mag width, 25.6 centimeters. And then we also want to fix this measurement. We don't want this to be 0.8. We want it to be the P8 AR mag depth. And the way that I'm doing this, I'm actually using the magazines in the CAD as a cutout. So that's why I'm putting in the measurements the way that I am. If I wanted to make a one-to-one representation of the magazine, I would just put in the real-world measurements. But I'm actually using these as a Boolean to then cut out the geometry that I need from the magazine well. And I can show you what that looks like. If I come up before this, and we isolate the magazine well, you can see there's no hole there. Then we roll this forward, and we've used the magazine itself as our reference geometry to make this cut. So now we can release or exit isolate. There we go. So the magazines in the software is not a perfect representation of the real world. They are booleans that I'm using to get the geometry that I need out of them. So we've got the P8AR fixed. Now we need to fix the P8SC. So let's switch back to that configuration. And close that folder, open up the P8SC mag. We don't want this to be 3.6, we want this to be P8SC mag depth, which will increase it just a little bit. And then we don't want this to be 2.4 centimeters. We want it to be P8SC mag width. Just gonna, again, increase it just a little bit. And that will update the Boolean so that now I can send these to the printer and test these fitments. So let's do that. Actually, it doesn't matter what I name it here because I'm just going to rename it when I actually save it. Yes, replace. And then change the config. Export this one. Okay, so now we've got, this is what I printed before, and if I reload from disk, we should see it update just a little bit. Okay, you know what, we're just gonna start fresh. Okay, and because of how they import from the CAD, they are levitating off the bed. I don't want that. Why did the music stop? Weird. It takes so I'm not actually printing the magazines. I'm printing the mag wells. There we go. We set those on the bed. Let's make sure we've got these set up correctly. I also want this to be Arachne. Ooh, I almost forgot something. For this magazine in particular, we need to accommodate the tooth on it. So we need to do a couple more things. Big odd job. I'm going to take that as a compliment. I'm going to assume that you were noticing that I was getting those gains in the gym and not that I was gaining weight. Which, speaking of, how's that for a protein shake? It's mostly water, but does have 2 scoops, so it should be 70 grams. Okay, so on the P8SC version, I've got this little channel that is supposed to accommodate the tooth. But it doesn't go high enough. And the problem with that is when we're inserting the magazine, I really hope no one's going to clip me playing with these magazines, because there is a lot of potential for very unfavorable memes. We need to insert the magazine deeper into the magwell. We need to insert the magazine deeper into the magwell. And so we need to extend that channel so that it allows the magazine to sit higher. So where's my calipers? So get 35 or 33.58, 33.6. I think that is close enough to... Okay, we're going to call that 33.9. We're going to add that 0.3 millimeter tolerance. So let's see. What I'm going to do is I'm actually going to have it start from this face, go the other way, and actually, you know what? For this part, I actually want it to go all the way through. So I'm just going to make that 5 so that we for sure clear everything. And then I'm going to create myself another variable. And Onshape doesn't like you putting spaces in your variable names. So what I'm doing here is called camel type. Not to be confused with anything else, but it's basically where you instead of doing a space, you do a capital letter every time you change words. So we'll just save that there, because we need to create the geometry that moves in order to reference that tooth. So I was getting a little ahead of myself. Yes, I want to replace it. Now I can go back to bamboo. And now if I reload from disk, there, see? It updated right there. Like this with coding, you do this type of thingy to, yeah, yep. It's a really popular thing in coding. That's actually where I picked it up in my intro to coding for MATLAB class, and I use it all the time now. Okay, so let's slice this. Looks good. So this will take 2 hours. So it's actually really quick. These are not showing the right ones. I just want to make sure that for sure recognizes. Ah, see, and that actually sped it up. Cool. Yeah, 2 hours is really good. And I should be able to share this on stream with you guys again. Let me try and figure out how I did that before. Okay, I think that I should be able to just turn on the printer. Oh, heck yeah, that's working. All right, cool. So we can have this kind of chilling in the bottom. Bring my face back. And while I'm thinking about it, this project is sponsored by PCBWay. PCBWay is your source for all the things that you could want to make. They do 3D printing. They also do PCBA assembly, which is you can have them do the PCB on its own, which is just the board, or you can have them do PCBA, which is when they put it all together for you. That's what I had them do for this. Let's actually take a look at PCBWay's site. Since they're sponsoring the channel, I want to make sure that I am making myself useful to them. So they do PCB assembly, electronic design, and they have a whole list of capabilities. They're a really competent company. You can have them do CNC, milling. It's really pretty cool. They also do 3D printing, and their 3D prints, from what I've seen, are really nice. Quite a bit better than what I am currently capable of being able to do. So, yeah, there is a link in the description. If you want to get 5% off your order, use my affiliate link and enjoy the services you can get at PCBWay.com. Back to the print. Also, I've done a few changes to my printer since the last time you've seen it. Down here, we've got a chamber heater that I added, which connects with this wire up to this monitor here. It does a couple things. One, it gives me a real-time readout of what the interior chamber temp is, but it also means that when I want to print stuff like engineering filaments, nylon, polycarbonate that requires a higher chamber temperature, I can go kick that thing on and it will get it nice and toasty. Other changes I've made is I've added this foil bubble wrap to the sides, and this is to reflect the heat back into the chamber, prevent it from getting lost to the walls of the printer. And obviously I do have some big gaps in the insulation near where the moving parts are. I'm not going to change that. I don't want to interfere with the movement of the gantry, but this does still do quite a bit. On the outside, I've also got some foam insulation. After doing these modifications to better print these engineering filaments, I was noticing that it would get really hot to the touch when you're using the printer. So I wanted to protect myself and others, so I added some thermal insulation on the outside to help with that. It also helps trap the heat inside better, so it makes everything a little bit more efficient, so I'm not just constantly running the heaters trying to maintain a temperature. So it's pretty nice in that respect. Let's save this as something else, actually. Save project as P8 Magwell instead of just one or the other. I also added BL LED to the printer. Ow! I just kicked my desk. That hurt. BL LED is a ESP32 based light controller, and I'm using it to provide myself with status LEDs. So right now this red color indicates to me that it is in the nozzle cleaning stage of its print. And so the print head is going to move towards the back, and it's going to do a kind of a white mechanic. Once it's done cleaning the nozzle, then it'll cycle through some other colors as it progresses along its setup stage. Let's see. At my school before, I had a friend who just had a printer that was who just had a print that was the entire build plate. It was just a big cube. It was a day-long print for like a 6-inch cube. Totally know how you feel, Wills. My first printer was an Ender 5 Plus, and I hardly ever use it because it is so slow. Compared to what my Bamboo can do, it's just not even worth the time to set it up. Okay, so now that we fix our tolerances, let's try and figure out some of the math that we need to be able to get these mechanisms to work. So switch back to screen 2, put you guys on the other screen so I can read what you're saying while I'm working. We're going to be doing a lot of trigonometry. So I hope you guys have your triangles ready. Using the depth gauge of the caliper, we can measure how high that tooth is. And it's 2.39, so 2.4 millimeters. I'm going to round that up to 2.5. Now, as far as a tolerance goes, this one is not as important. But if I make it 2.5, I will for sure clear it when I have moved it by that much. So essentially what I'm saying is, let's see, I need to decrease the opacity on these guys. And what was layer 7 doing? I don't think it's doing anything actually. I think I just added that one. So what we're trying to do is we want to get this piece here to move by 2.5 millimeters. Okay. And we have this distance that we've yet to determine. We'll call that Y. And we've got X. And we quickly see that we really need to know how much this distance truly is, that this piece is allowed to move vertically. So in that vein, it would be very helpful to have some reference geometry that we can look to. So let's create a new sketch on the right plane. And I'm gonna intentionally make my lines sloppy to start with because I don't want to get stuck with any relations I don't want, like that one. And then I can make them reference the things that they are supposed to. Interesting. It looks like this is not a... It looks like this line is actually horizontal. So instead of making that perpendicular, I should probably just make that horizontal. That seems to match the shape better. Weird. And this one seems to be vertical too. Okay, let me pull up another picture because I want to make sure I'm looking at that right. Yeah, it's definitely not perpendicular to the magazine slide. It doesn't look like it's totally horizontal either. I think I'm going to take some creative liberty here. Because it is such a small difference, I don't think anyone's going to notice. Except everybody now watching, I guess. I'm going to make these all reference the magazine well. Because that's going to make the movement of these mechanics a little easier. And let's see, let's take a look at that picture again. I think I have a bigger picture. One of these is bigger. There. This one's pretty big. Oh, yeah, and I really like this one because it shows very clearly what is separate parts. So we can see very clearly here, for instance, what the black part is. That's what's actually going to move. And so for now, we can draw it as coming to a point because we can add a fillet to it later. I think what is going to be best is if I model the whole first and then do the moving part. Actually, you know what? Let's not do that. Let's make these two lines parallel. Okay, so now this is locked into place. We can extrude this as a removal. big screen back. There we go. So we're going to extrude this as a removal. I want to work on this side first. .35 looks about right. And it's really angry with me right now because the radius of this fillet is way too big. Let's try 0.2. Seems like it's happy with 0.2. And 0.2 does seem to match up pretty well with what is in the reference photo. So we'll make that permanent. And then we're going to mirror these features. Across the right plane. And now we have a matching slot on the other side. Now it added these into the P8 SC Magwell folder. I don't want them there. So we can drag them out like that. There we go. And now let's go back to this sketch and we're going to add our I want to make that 0.3 so that I have just a little bit more leeway. So this should be allowed to move 0.3 millimeters up and down. We're going to make a new piece by extruding this. We'll set it to 0.5 so that it sticks out from the side just a little bit. Just a little bit for now. We'll make it a bit more tactile in the future. We do want it to be new. And here's another cool trick. If we move this up above fillet 3, then we can then edit fillet 3 and include these guys. Like so. And then we need to also include extrude 13 in order to properly include fillet 3. So now we have part 10 over here, part 9 on the other side. And these are our sliding mechanisms. Oops. Okay. Oh, yeah, printer is doing, it should still be doing its calibration. Let's see, it will tell me, it's saying first layer defects were detected by the micro LiDAR. I've noticed that it really struggles with the translucent filaments. So I'm gonna go check that real quick, just make sure it's not eating itself. I'll be right back. Alright, everything's happy again. It was fine. Like I said, it struggles with the translucent filaments. Let's go to screen 2. Okay, so now, because of how we designed it, this distance is now known to be 0.3 millimeters. Okay. So now we need to get this swinging arm to fit inside this narrow section here, and it needs to have its movement contained within this thicker section here. So we don't have a lot of room to play with. I think we'll be okay, because I can make a rather tall part to get it to be rigid enough. But if we can simplify this drawing a little bit into a triangle of x by 0.3, and we want to know this angle, and we want this angle and our vertical triangle angle to be the same. So let's see, in this case we want, let's call this angle alpha. So alpha, we've got adjacent and opposite. So it's going to be tangent. Tangent of alpha equals 2.5 over y. Nope. Wrong. So y tangent of alpha equals 2.5. We also have tangent of alpha equals that can be 3. I need to keep my dimensions consistent. Equals 3 over x, opposite over adjacent. So x tangent of alpha equals 3. And ultimately, we are solving for y, and we don't need x to be anything specifically, but we do want it to be at least the depth of our magazine. So we determined that to be 30. What do we call it? We said that that was 36.4 millimeters. So yeah, I think if we set it equal to 36.4, I think we're going to be okay. So if x equals 36.4, then this equation here simplifies okay, so I do actually need to arctangent of three over 36.4 equals alpha. So if we pull up Desmos, and make sure that we're in degrees, 4.7 degrees. All right, cool. I think it was 4.71, right? Yeah. Okay, then knowing that, we can figure out why. Because if we know that alpha equals 4.71, that equal to... Like, this is what we had before, right? Then we can divide 2.5 by tangent of 4.71, and we get y. So I'll open up Desmos again. And we get 30.34. Millimeters. Yeah. Okay. Switch back to the main screen. So from the right side, or the right plane, we're going to draw some reference geometry. And for now, I want these two guys open. These are parallel to each other, or perpendicular. These guys are parallel, and these are actually incident. Make that transparent. Go back into this. Oh, I don't want that to be transparent actually. This is going to be 30.34 millimeters. This one is 36.4 millimeters. Nope, not meters. Screwed something up. 36.4 millimeters. There we go. I just thought of something. And I don't know if it affects anything. I don't think it actually does. So I'm going to keep it to myself. And because I'm trying to maximize the strength in one direction, instead of having it be thin or short on the sides, we're actually going to make it quite tall. Because we can. That's kind of the only direction we can expand. Where's this thing coming from? Just going to delete that. Oh, it's part of the... Make these guys tangent to each other. Right? Oh, actually, I don't want these parallel either. Shoot. Let's just redo that line then. This dimension can be whatever I want, so I'm just going to make it 0.4. This needs to be greater than the angle we determined, so I'm just going to make that 5 degrees to give us a little bit of a buffer. And I want to add a radius to this guy because bigger curves are stronger. I don't know why this point still shows as undefined. We're going to remove some geometry from Magwell. We're going to extrude this symmetrically by mag width depth, or at P8 SC mag width, plus 0.25 centimeters. And I want it to be this face, this face. I want it to be all of those. And I wonder if I can get away with 0.5 centimeter. That would be pretty sick. Oh, looks like I can. Sweet. That doesn't create any aesthetic problems across the bottom. I want to increase this offset a little bit though. And then we're going to create one more piece of geometry here. Make those guys parallel to each other. Set this equal to 0.25. Take a look at that on the inside. We want to include this shape as well. Ooh, I'm gonna need to carve out space here too. I'm gonna do that while I'm thinking about it. Doesn't need to be horizontal. It needs to be what I tell it to be. To actually be the same. I do want these guys to have a relationship to each other. So what I can do is I can set these two lines equal to each other. And I can make the angle between them 5. That does not need to be perpendicular to that. These two are incident. And there we go. That should work. Did that work? No. I don't think it did. There we go. That's what I was missing. That should be a fairly accurate presentation of how it's moving. And that's gonna, yeah, totally wreak havoc on the extrude function we've got here. We just need to add additional faces to our selection. There we go. Select sketch 12 again. We're going to do another extrude. This time we're only going to select this circle. And right now I just want it to be there. Actually, you know what? I need to make another circle here. This circle. So this will be our pin that the that it's allowed to ride on, the mag release. And I don't think we need to do a whole lot to constrain it because it's going to be pretty deep inside the gun, so it's not like it's going to have an easy time falling out. Matching pin on the other side. And we want to do another extrude with this face. Yeah. So all of those faces. I want to create a new part. And our starting offset is going to be this entity, 0.25. And then we're also going to want to mirror... Well, actually, no. I can do this a little more cleverly. If I extrude this face in the opposite way up to... Actually, I think I can do up to next. Add it to this guy. Okay, I do need to do up to face, and then I need to click that one. Include that in my selection as well. And then I can mirror this. I don't want to reference a sketch. I want to reference my principal plane. Okay, that should be a working magazine release mechanism. So let's jump into our assembly here. Actually, let's go back. Let's name this. So this is part 11. Oh, but you guys should be... You guys should be the same part. So this is our magazine catch for the P8 SC. Now we can jump into our assembly. Let's insert that. So this is the part we just designed, and what'll happen is when the magazine tooth slides up past this bar across the middle, it's going to push it forward, and then the spring tension from our principal spring in this whole assembly will push it into the catch position after it glides past. So this should actually work. The best laid plans always run into some issues though, so I am prepared for that. Let's hide some of the airsoft parts I added in here. Let's mate this to... Let's see, so we'll add a revolute mate there. And we'll connect it that way. So we should have enough clearance that this is allowed to move. And it should be able to move 5 degrees, no more. And when it moves 5 degrees, it should just clear the tooth. So I think we are set on that part. Okay, actually, I know what I should do. I should... let's isolate these parts. Then we'll make the magwell transparent so we can see a little bit better how it's moving. Where is it? Am I just blind? Alright, well, let's just look at it from here, I guess. So we just want to check. We can see that it's intersecting here. So that is not how far it's allowed to go. It's about there that it's supposed to stop. And it looks like we're okay as far as I can tell. All the areas that it's supposed to move, it looks like it's okay. It is possible though that there's going to be some rubbing here. The way I'm going to fix that is I'm just going to make a bigger fillet there. I think that that's going to be the easiest way to fix that. Let's see, that fillet is actually defined by a sketch, so I need to change it there. So we make it tangent to these two sections. It should give us enough of a gap. Let's just make sure that we include it in the selection here. And if we go back to the assembly, we should see that that's cleaned up a little bit. Yeah, that looks good to me. I might need to do some light sanding on the magazine catch piece on the outer sides, just to give them enough clearance to move smoothly. But that's not going to be an issue. That should be fine. But that should totally work. I'm pretty stoked to see that. Yeah. One thing I do notice is it looks like the extrusion of the magazine through the upper receiver might need some work, because we've got a little bit of a lip here. That might not be an issue. No, it definitely is, huh? So let's adjust that then. That is this extrusion. Okay. Yeah, I need to not do that as symmetric because that's causing me issues. Actually, maybe it's fine. Alright, well, let's just Boolean the magwell to the receiver. Subtract the magwell from our target. We want to keep the tools. Oh, no, okay. I think we're good then. Well, something clearly is colliding here. How can I fix this without having to redo a bunch of work? Let me hide this so that we can see our geometry a little better. Here's what I'm looking at. The mechanism we just made to release the magazine, it's clearly intersecting here. I don't think it should, but clearly it is. I think what I can do is I can extrude the top face of... Let's play around in the assembly, see if it's causing the issues I think it is. You can see it's clearly inside that other piece. Can't have that. Okay, I think what I can do is I can combine... the extrude that we just did to create a pocket. Can merge this to upper receiver as well. extrude up to the right face. Starting offset set as wait, cancel. Okay. I wanna do that differently. Oh, that's right. We set this as a so I think as long as I include the upper receiver, I think I'm actually good. Yeah, it might rub a little bit, but I think we're set. Hey Ivan, welcome to the chat. How you doing? We are making a P8 SC and a P8 AR from Star Citizen. So let's see. We are making this. What do you think? That's right, my dude. It's going to be pretty sick. It's going to be pretty sweet. I'm going to try and make it as functional a prop as possible. So I've got some airsoft parts here. Printed some dummy cutouts so far. This is our stand-in for a P8 SC magazine. So it will be a working airsoft replica. So it's going to be pretty fun. If I ever get to go to CitizenCon, maybe they'll let me set up a booth where I can show it off. I don't know. Could be cool, but that's way down the line. Right now, we are working on getting the magazine catch working. So, to anyone that's new to the stream, we've got a tooth on the side of the magazine there that we need to catch. So this gray piece that we've just made will allow the tooth to slide past because it's got a slant on it. And then once it passes, it will move back into position under spring tension to keep the magazine locked into place. So it should be pretty secure. Let's take a look how our X1C is doing. It's chugging right along. We should be able to test our improved tolerances in just a little bit. So now we need to tie all these parts together. And trying to think of the way I want to do this. Let's look back at our picture here. So we've got a little divot here. It doesn't look like on the game model it's functional. Like it doesn't imply that there's a screw there, except that it looks like there might be a little pin. So let's replicate that detail because that's going to be how we connect our two halves together. Let's let's bring back sketch 1. Those like so. Make that guy horizontal. It's some catchy beats, right? Thank you, oh, what's his name? Harris Heller from Senpai Gaming. Just add a mental laugh after that one beat drop, yeah. Actually, don't want to dimension that. Instead, what I'll do is I'll pull that onto there, and then it doesn't matter what the dimension is. I'm gonna call this 3. Let's see. If I get a 3mm steel pin, which is probably going to be the best way to assemble that, I want to make a interference fit so it doesn't come off. Or is that the best way to do that? Because if it ever did come off, that's going to be a pain to fix in the field. Let's call it 0.3 for now. I'll come back to that. I'll have to brainstorm. The lower receiver. No, I forgot to reference some other important geometry I need. Heck, sketch or convert. Why is that not doing what I think it's supposed to be doing? Oh, I was using the wrong one. There we go. fighting me. Guess I can do it this way. And I'm going to adjust the apparent angle a little bit, because my worry is that if this is too shallow of an angle, your finger's going to slip off too easy. And I want this to be usable. Apparently I need to create another sketch. Let's reference all those. Let's just make this some distance. Doesn't matter. Okay, now let's do that sweep command. There we go. That should be cleaned up enough that now it won't fight me. Bothers me that this is not tangent. Why is that? I think I can fix that by changing this angle. Yeah, that looks a lot better. It's not perfect, I guess, but now I can't tell, so I don't care. Just do it. Nope, that didn't work. Okay. Do you want to reapply then? let's actually do this. Let's delete that. And then we'll mirror this body. There. That works. Need to lock my backrest. There we go. Now it's a little more supportive. All right. So then we need to. I'm gonna roll back to before this. Let's edit sketch. Oh wait, no. Actually, we don't need to edit that. We need to instead come on. Is it not letting me click? There we go. Through all, make it symmetric. Merge it only with this part. Okay, why did that not work? Oh, because I unselected it. That's what I did wrong. Then if we roll it back, now both pieces have that 3mm pinhole through them. And I think what I ought to do is actually make that 3mm pin into a slot in the lower receiver. That sketch now, and that one. So this is the first of our cam profiles. And we want these to be concentric with this, but we don't necessarily want them to be the same size. We do want that to be our 0.3mm distance. And I'm going to make this 0.2 for our radius. Actually, no. 0.175. Well, now I'm breaking my own rules. Let's see. If it's 0.3, if it's a 0.3mm pin, I know it's going to be exactly 3mm because it'll be a 3mm steel pin. So the radius, I think 0.2 will give us a good glide. All right, thanks for hanging out, Wills. So if we now hide our buttons, now we have a little bitty slot. There we go. Now it goes all the way through. So this will allow those two buttons to move up and down. Why am I missing a hole on this other side? Let's mirror that, I guess. Across the right plane. Oh, I know what it was. I deleted that mirror from before. And so that screwed things up. Okay. I want to also include fillet number 3 then. There we go. All right. Now we're symmetrical again. So now let's hide our magazine. We need geometry that is able to slide in the middle here. So let's pull up some reference images that I took. Wait for these thumbnails to load a little bit, I guess. There's one in particular that I'm looking for. If you reload and catch the right image, oh, come on. Let's see. How do I make the icons bigger? What am I missing? Oh, view. Here we go. Extra large icons. There we go. All right. One of these, I caught the front geometry of the rails where the magazine kind of slides through. I thought I did. Oh, you know what? No, actually, now I remember. I actually already moved that over. All right, so just behind our magazine, we have this kind of rail pattern. And it looks like, based off of what I can tell, this is a little bit of a window here. So if we look at this from the bottom of the mag well, it evenly divides it into 1, 2, 3, 4, 5 sections with 5 lines. and then this is cut out, right? So this will give some more clearance for our magazines, which is good. I'm gonna change it a little bit to make it so it doesn't mess too much with what we've already got going here. And then we're going to define this as our, let's see, we need it to be the magazine width, but we want it to be the larger of the two. So our AR mag is a little bit wider, so we'll use that one. And then we want this line and this line to be the same. Go. Move through all. And you know what? I actually don't think I want to worry too much about making this specific detail match up aesthetically, because if instead I just make it functional, I think that that's the most important thing. There's going to be a magazine in front of it most of the time anyways. So this is one of the concessions I'm going to make in order to focus on making this thing functional. If I extrude that straight back, still got a little bit of a clearance there, but that's not a lot of material to keep this thing from breaking. So we want to increase that a bit. Let's do it like that for now. And then we'll make these not incident like that. That 1.5 centimeters should be big enough to make a decent sized part. Checking the status real quick of the Alright, I'm gonna take a quick break to go check the printer. It's saying that the AMS unit is stuck, so I'm gonna go fix that real quick. You can watch me on the little red camera for the printer. It shouldn't take long. I'll be right back. So this little piece was the problem. I don't know why, but Bamboo Labs, their infinite wisdom, decided to give the end of the filament a little bend, which prevents it from being taken into the AMS properly. So what should happen from here is it's now basically empty, so it should switch over to this other roll and continue rolling with that one. Oh, and you know what? This shape needs to not be... needs to be a little different. Oh, come on. There we go. So let's make these vertical to each other. Now it's centered. And I actually want to make this line incident with this edge way up here. And then I want to adjust the extrude to include all of that. So now I've got lots of room to make my mechanism for moving this stuff around. But I don't want it to cut so deep that it's visible here. So let's reduce it just a little bit. I don't want the magazine there, actually. I just want to be able to see this part. I think what I wanted. Why are you doing that, Mr. Gimbal? How are you running low on battery? Alright, well, I'm going to need to retire the gimbal, so I'm just going to move the camera around for a minute. It's a decent enough camera angle, right? What was I doing? Oh yeah, okay. Okay, so from this face, let's create a new sketch. And I want to include these guys. Well, no, actually I don't want to include all of those. I do want to include just that line though, and this line. I really want to hide this sketch again because it's in the way, or the image. Actually delete those because I can mirror this and that'll be more efficient. And let's actually not use that line because I actually just want it to go all the way across. Oh, that's how I was able to see it before. All right. Okay, so let's reference a midline instead then. Then we'll mirror these. Wait. Select mirror line first. Move it from this piece, the upper receiver, and lower receiver, and go up to this face. I don't like how it's carving a little window out of there. That's not good. And I can't really reduce that extrude any more than I already have. Try one. And that fixes the window almost. But then we're not getting the full clearance that we need for our pin. But we have to include the magwell in it, because otherwise we're not getting all the parts we need. What to do? Well, I guess, actually, I only need this bottom section to have that much clearance. So this top section I can actually do by even just that much. No holes. And then down here, let's just add another line to include this line and that one. And then show that sketch, do another extrude of these two sections. Now we've got lots of room for those to move. Now I want to create an offset of these surfaces. And I want to offset them by 0.1, which would be 1 centimeter. Now, surfaces are not printable in this format. We need to do some work with them to make them usable, but we can turn this into a solid. Though I will be the first to admit that surface modeling is not my forte. Extend this as well. Maybe that's not how I want to do this. Let's delete those. Let's not do it that way. This. Okay, let's just do a sketch from here then. Our part is allowed to move 0.3 centimeters, but because I don't need it to be super precise, I'm just going to give me lots of room to move it and only worry about constraining it where I have to. That's going to be how we reduce friction as much as possible. For instance, here we'll set it to 0.3 millimeters so that on either side we get that tolerance. This should be allowed to slide up and down pretty smoothly. Make these two equal because they are going to be doing the same thing on both sides. I'm realizing a problem, but I don't need to fix it yet. So I'm creating this little comb shape, and that's going to grab the top and bottom of this swing arm. And I need to build some more tolerances into this. And I'm just going to leave it as 0.3 millimeters because I actually want this to be a pretty tight tolerance. But over here, I don't need those to be that tight. Don't actually want this. I don't want those to be equal because I actually want the distance between these two guys to be at least 0.3. You guys should be parallel. Why aren't you parallel? Okay, let's reference this one, I guess. Crap. That's an issue. Okay, I'm going to come back to that because I think I know how to fix it. Actually, let's cancel those changes. And let's dive in again. Let's actually just make more geometry down here. That's looking better. Now let's come back to this one. Now let's actually just make these guys equal, because now we have space for it. So the key here is at the contact point, which is where this plane and this plane intersect, we want the total vertical travel to be 0.3 centimeters or 3 millimeters. So we don't actually care too much about what happens behind this plane. We just need to make sure that whatever we do allows that to happen. So what I can then do with this shape, send it back the other way, and we'll do up the face, but with an offset distance of 0.3 millimeters from this face. We exit the isolation. Let's hide the upper receiver. So now we've got our little comb. Should have enough tolerance on all sides to be able to move the way that it is intended to. It's kind of a chunky boy, so it should be able to do the movements I'm expecting it to, or it should be able to handle all that force. Now what we want to do is we want to extrude. Hold on, where's my isolate? Ah! Shoot, let's not do that. Wrong button. Let's isolate this part. And then let's extrude these two faces. I think I want that to be 10 millimeter, or 10 degrees actually. And that should give me just a little bit of a taper so that it doesn't impede the movement. But let's send the direction. Send it that way. And let's now isolate these two pieces. See how they're looking together. I think that should work. It might need a little bit of adjustment, but I think that that's to a point where I would like to print it and find out later. You know, like we've done enough work that it's probably good to do some testing before I fiddle too much with that. But in theory, what should happen is when this is pushed down, this will rotate, allowing the magazine to drop out of the bottom. And that will be the main function that allows us to use this as a airsoft gun as a P8 SC. Exit the isolate there. Make that transparent. And then on this face, we're going to do a new sketch. That's not gonna work. Oh, but if I project those, and then I can make these construction geometry. Okay, so this will allow the pin to come through as a crossbar, and I just need it to extend up to the midpoint of the pin. And it's got a tolerance on both sides to allow it to be nice and loose, so it shouldn't be a lot of friction there. And then when you push these buttons down, remember they have a pin that goes all the way through, so that will pull the blue plunger down. When that blue plunger goes down, it will pull these gray arms down, which will release the magazine catch. So in theory, this is all a working release for the P8 SC. I still need to do a little bit of work to it because I need to get it so that it is interacting with the spring. It's not doing that yet. Let's see if we can get that going. Well, no, I need some imagery of the other side. Let's see how this guy's doing. Oh, it's done. I'm gonna go grab the magazine, the mag wells. Be right back. All right, fresh off the printer. Let's see how our fits are. So it's definitely less movement. I'm hearing a bit more rubbing, which, I mean, we did tighten the tolerances a little bit. I am pretty happy with the AR magazine fitment. So I would call this a win. Let's see, why isn't that? So it's enough that it'll actually stay in there, but it's still pretty easy to take out, which is perfect. With the SMG one, oh, again, just about perfect. This one is a bit looser than the AR one because it has that trough for the tooth. But we've definitely got clearance that we didn't have before, which is good. I don't know if you guys are going to be able to see that. Yeah, that is great, actually. So I'm pretty happy with the fitment of those. We can call that part done. Let's see. Is there anything else I can get done tonight? My brain is kind of melted, so I'm trying to think. Can I keep going, or do I need to stop? I think that this is probably a good stopping point, at least on the stream side. I'll probably come back to you guys next time with a bit more work done, just like I did this time. Reason why is because I can think a lot easier when I don't have to record myself. But we've made a lot of progress. I know it doesn't seem like it. CAD can always feel like that sometimes, but we actually did do a lot. Let's kind of review what we've done so far. Let's exit our isolation here. Did I isolate it? Oh, yeah, okay. I just went through and clicked them all to be gone. So we've extended the tolerances of our magazine well on the P8 SC. We've reduced the tolerances on the P8 AR magazine well. We've made these buttons that are going to be the actuation points for releasing the magazine. We'll be tying those in the future to the button up here so that they all work together, and we can have the spring up here. We've got the comb that connects these two buttons to the mechanism that releases the P8 SC magazine. We've drawn up some plans for how we're going to accomplish the same thing with the P8 AR. So we know how we're going to do this. It's going to be a little bit different, but same idea. We did quite a bit of math to figure out exactly how big this swing arm needs to be so that we can design it right the first time. So I'm pretty content with everything that we've been able to achieve so far on stream. I think this is probably a pretty good stopping point. Let's kill the music. Like I've mentioned in the past, this is sponsored by PCBWay. So if you are looking for any PCBA assembly, PCBWay is who I am using at the moment, and they've been really good to work with. I've been pretty happy. Their work is quick, high quality, and I have no complaints. the only complaint I would have would be in myself for not knowing as much as I wish I did about PCB and PCB assembly. But this is what they've made for me, and it is perfect. It does exactly what I need it to. They also do CNC, 3D printing, all kinds of stuff. So if you need it made and you don't have the machine to do it, PCB way. Oh, I should have had my OJE logo up the whole time. I didn't. Shame on me. Well, I guess no point starting now. Channel members get exclusive access to... Oh, nope, that doesn't look good. We're going to run that again. I'm going to hide the printer cam because it's not doing anything anymore. And let's hide PCBWay. Our channel members deserve their proper runway on the screen. Channel members get exclusive access to videos that I upload periodically. A lot of them are focused on quick engineering tips, but it also supports the channel and enables me to make future content. So I know that the CAD probably isn't the most engaging stuff to do on stream, but it's going to turn into some really awesome videos in the future. So stick around for those, but I always want to say thank you to our channel members. Right now we've got 2 at the Orbital Bombardier tier. John Best and the Prime Orbital Bombardiers and higher get a special mention in streams and videos with this little animation motion graphic you just saw. Of course, don't forget to like, share, and subscribe. Do all the YouTube things. Let me know what you think down in the comments below. If you have any thoughts about the design so far, I'd love to hear it. If you have any expertise or input, if you think I've missed something, please share, because I would love to. I always love to get ideas on how I can work more efficiently, work faster, and get more projects done. But with that, guys, this is Odd Job Entertainment signing off. Oh, nope, shoot, click the wrong button. This is Odd Job Entertainment signing off.